All right, correlation was all about the linearity of paired data. Regression is all about finding what that straight line is, finding the equation y is equal to mx plus b, right? Because if we're finding the equation of a straight line, the equation of any straight line is y is equal to mx plus b. So we need to figure out the m and the b that gives us a relationship between the x and the y. So our two equations, in fact, we have a few different equations. The equations that I will use, the m value, the slope of our regression line, will be n, the number of data pairs, times the sum of the x times the y's, minus the product of the sums of x's and the sums of y's. Now, notice that numerator right there is the exact same numerator as your Pearson correlation coefficient. So if you've already computed your Pearson correlation coefficient, then half your work is done. We are going to divide this by n times the sum of the x squareds minus the squared sum of x's. And also note that this denominator is the first term in the product of the denominator of your Pearson correlation coefficient. So if you've done your Pearson correlation coefficient equation, then you know the numerator and the denominator. You can solve for the slope of the regression line with just maybe 2 algebra steps. Okay, now notice here in your slope equation, it does depend, or it does matter what you call x and what you call y, right? Your numerator can't tell the difference, but your denominator doesn't have any y's in it. It only depends on x. So when you're finding the regression line, make sure you pay close attention. What's the variable that you're trying to predict? You need to call that y. The variable that you're going to feed your line to predict those y values, those are the x values. Okay, let's get started. Oh, that's just the m equation. The b equation, or the y-intercept of the straight line, the one that I like to use is the average of the y's minus the slope that you just found times the average of the x's. All right, let's go through this. Let's find the line of best fit for the data given here. So look at your slope equation. You need sums of x's, sums of y's, sums of x times y's, and sums of x squareds. So let's build ourselves a table like we did for the correlation value. We'll give ourselves x values. So 1, 9, 5, 3, and 7. We'll give ourselves y values. 1, 5, 4, 3, and 2. We need x, y's, and x squareds. So go ahead and pause the video if you'd like and fill out the rest of this table with me. And at the end, give yourselves sums. Okay, so we have those sums. Let's figure out this slope. So the slope will be given by, we have 5 paired data. The sums of the x, y's is 89. The sums of the x's is 25. Sums of y's, 15. And I divide by 5 times the sum of the squared x's, 165. And I subtract the squared summed x's, so 25 squared. Now, when you go through the algebra here, in fact, I'll go through it in steps. Your numerator becomes 70. Your denominator becomes 200. So you get 0.35. So positive slope. That means our data is directly proportional. Let's figure out the y-intercept. The average of the y's, I already have the sum. I just need to divide 15 by 5, and I get an average of 3. The m value we just found to be 0.35. And the average x's, I need to take 25 and divide by 5. That gives me 5. So the b value that we get, y-intercept value of 1.25. So our line is y is equal to mx plus b. We figured out that the slope of the line is 0.35, and the y-intercept of the line is 1.25. Now let's plot this data and the line to make everything make sense. Now our y's were the 1, 5, 4, 3, and 2. So if we were to plot some data, those are y's, these are x's. Let's run this one up to 10 and the y's up to 6. We see our plotted data looks something like this. So it makes sense that we have positive slope because it looks like that's directly proportional. So that positive slope makes sense. And if we were to plot the line y is equal to 0.35x plus 1.25, we get this, right? This line, that is this equation, right? Where that y-intercept is that 1.25. And the change in y over the change in x, the slope of that line is that slope 0.35.